This lesson is going to talk about trigonometric ratios, and we do a lot of this with triangles, and finding sine, cosine, tangent, and things like that. But before we do that, I want to review special right triangles. Special right triangles are ones that have specific ratios and angle measures. So in the two special right triangles we've talked about before are the 45-45-90 triangle, which is it's an isosceles triangle because the two base angles are 45 degrees. What we know about this is the ratio of the sides is always, the isosceles triangle means these two sides are congruent, so they're both n or any number, and then the hypotenuse is always the length of this side times the square root of 2. So that's a good thing to remember and know. The other one is the 30-60-90 triangle. If we have a triangle that has this angle right here is our 30-degree angle. It's kind of hard to see that. And this one is our 60-degree angle, and then our 90-degree angle. The shorter side, or the side opposite the 30-degree angle, whatever that length is, the ratio of the sides is the length, and then the longer side is that side times the square root of 3, and the hypotenuse is twice the length of the shorter leg. So I would write that in your notes and keep a track of that. It will help you as you go throughout this lesson. So if we're going to determine side lengths of special right triangles, this is a 30-60-90 triangle. And so what we know is our hypotenuse is 10. So if I were to write this, I could say that's 2n. Our shorter leg, the one opposite the 30-degree angle, is n, and this would be n radical 3. So what are the other two lengths after this? Well, if we know that this is 2n, then we say 10 equals 2n divided by 2. So n is going to be equal to 5. So our shorter leg is equal to 5, and then n radical 3 is 5 radical 3. So AC is equal to 5, and BC is equal to 5 radical 3, just because we know that this is a 30-60-90 triangle, if we know one side length, we can find the other two. So now let's look at labeling side lengths of right triangles. We've talked about like shorter length hypotenuse, but we're going to be talking about opposite sides, adjacent sides, and hypotenuses. So the hypotenuse is always the longest side. So C, when we're looking in reference to angle A or angle B, C is always going to be the hypotenuse. So that's taken care of. Now let's look at angle A. If we're looking at angle A right here, we want to find the side opposite. That is, so these two lines form the angle. So the side opposite is the one that is not part of the angle. So in this case, the side opposite of angle A is side A. And that means the adjacent side is the side that forms the angle that is not the hypotenuse. Because remember, this longest side is always the hypotenuse. So the other side that helps form the angle is called the adjacent side. So now let's look at angle B. So now if we're looking at angle B, what side is opposite? Well, side C is our hypotenuse. Side A forms that angle, so the side opposite is B. And A helps form that side, so that is side adjacent. So depending on the angle that you're looking at, opposite and adjacent will be different. But hypotenuse is always going to be the longest side or the side opposite of the right angle. So let's practice writing some ratios. So if we're looking at this triangle LNM, which statement is true? Which statements are true? So we're going to look at, here we have angle L, the side opposite angle L would be this one. Is that NM? Yes, that is true because it opens up and this side is not part of the angle that forms L. Is the side opposite angle N, so now we're looking at this angle right here, the side opposite that, is that ML? Yes, that's ML, so that one is also true. The hypotenuse is NM. Well, here's NM. Is that the hypotenuse? Is that the longest side? No, the hypotenuse is going to be LN because it's opposite the right angle, so that one is not true. And the hypotenuse is LN, that one is true. So now let's look at it. So we did opposite sides, now let's look at adjacent sides. The adjacent side, so let's erase this here. The adjacent side of L, so here's L, again, the adjacent side, here's our angle, so our adjacent side should be LM. So is that NM? No, our adjacent side is the one that is part of the angle that is forming L. And the side adjacent to N, Again, here's our hypotenuse. So our side adjacent to n is nm. So that one is also not true. So I want to take a look at sine, cosine, and tangent functions. When we're talking about these functions, we're talking about angles. So the tangent of b is talking about angle b. So all of these, we're looking at angle b here. And these are the ratios that we'll find that. So sine of b is the opposite over the hypotenuse. That's why we need to know opposite. So here's our angle b. We're looking at this angle right here for all of these. So our opposite would be AC, and our hypotenuse is AB. That would form that ratio. Whatever those lengths are, that would be the sine of angle B. The cosine is the adjacent. So here's our adjacent side, would be BC, and our hypotenuse is still AB. And finally, the tangent is the opposite side over the adjacent side. So in this case, this would be AC over BC. So depending on which angle you're looking at, you need to know the opposite side, the adjacent side, and we always know the hypotenuse. This right here, I would write it in your notes if you don't have it. It's just a little phrase that helps you remember. SOHCAHTOA, where this stands for sine, cosine, and tangent. The first letter stands for the trigonometric ratio we're talking about. And O stands for opposite, H is hypotenuse, and A is adjacent. So it just helps you remember, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So I would write that in your notes because that's what we're going to be doing. We're going to be looking at an angle and we're going to find this ratio, and so we need to remember those. So here we have a triangle, XYZ. So what are the ratios of sine, cosine, and tangent for angle A? Make sure you know which angle you're talking about. So we're talking, angle A, angle Y. So here's angle Y right down here. So let's look at what side is opposite. First, let's identify the hypotenuse. Well, here's our hypotenuse. It's the longest side. Now, in relation to angle Y, these two sides form the angle, so the side opposite would be the one over here that does not form part of that angle, and then our side adjacent will be here. Once we know that, I want you to pause and mark the one that shows these. All right, in relation to angle Y, these should be your ratios. Opposite XZ over XY is the hypotenuse, cosine is YZ over XY, and tangent is the opposite XZ over the adjacent YZ. So here's one of our special right triangles. We have a 45 degree right triangle. So which statements are true? Well, let's fill in the information that we already know without even looking at the trigonometric ratios. If this is a 45 degree right triangle, then those two sides are equal, so this is x, and we know our ratios form x radical 2. Now let's take a look at what it says. Is NMX? Yes, that one is true because this is an isosceles special right triangle. If NM is x, can it be x radical 2? No. Is LM, that's the hypotenuse, that is x radical 2. That's correct. Now the tangent of 45 degrees, one of these is probably correct and one of them is incorrect. So the tangent of 45 degrees, we could use M or L. It does not matter because they are the same angle. And we just need to remember that the tangent, remember TOA, tangent of 45 degrees is going to be the opposite, which is x, over the adjacent, which is x. And what does x over x reduce to? Well, that is equal to 1. Anything divided by itself, that equals 1. So here we go. Let's try this one. What is the value of the tangent of 60? Now remember, this is a 30, 60, 90 triangle, and we have two of the sides labeled. What about the third side? We need to label that first. Remember, this is n, 2n, so 6 and 12. 12 is twice 2, and this should be n radical 3. So this is 6 radical 3. Once we know that, then we take the tangent of 60 degrees, so we're looking at angle B here, and we're going to take the opposite over the adjacent. Well, in this case, the opposite is 6 radical 3, and the adjacent is 6. And if we simplify that, we get radical 3. 6 divided by 6 is equal to 1. So let's analyze cofunctions. Cofunctions mean that if we have two angles, 42 and 48, that add up to equal, they add up to equal 90 degrees. So the two angles that are not the right angle, cofunctions mean the sine of one, so the sine of L is equal to the cosine of the other angle, in this case, M. And the same thing, the cosine of L is equal to the sine of M. And we could go through this and we could say because L is opposite, sine is opposite over hypotenuse, and the cosine of this is adjacent over hypotenuse. Well, notice in this case, the opposite angle of L is the same thing as the adjacent angle of M. So those are called cofunctions. The other thing to always remember is that because this is a 90-degree angle, these two angles, the other two angles, are always going to equal 90 degrees. So in this case, the sine of L is equal to the cosine of M, and the sine of M is equal to the cosine of L. So that helps you find things out really easily. Okay, based on what we know about cofunctions, I want you to take a look at this. Which triangle has an acute angle for which sine and cosine ratios are equal? So that means that if the sine and cosine ratios are equal, then they have to be like, for example, the sine of A has to equal the cosine of B, and the cosine of B, or cosine of A, has to equal the sine of B. And which does that work for? Well, that only works if we have equal angles here. So this is the one of our special right triangles that makes those so they're always equal. So I want you to pause the video and try to see if you can figure out these ratios of these similar right triangles. So based on this, if we found the value of the tangent of A, it's the opposite over the adjacent, so that's 3 over 4. Now in our next triangle, which is a similar triangle, we find the tangent of X is 6 over 8. And if we reduce that, that actually equals 3 over 4. So the true about the two tangent ratios is they are equal. So if we have similar triangles, because we're basing it on angle measures, similar triangles are going to have equal trigonometric ratios. So that's helpful to know. So when you have a similar triangle and it says what is the sine of A, and we have no sides written here, because we have a similar triangle, we can know that the sine of A is equal to the sine of X, because if these are similar triangles, then we can find that out. So we can find the sine of X is 6 over 10, which is 3/5. So that means the sine of A is also 3/5. So if you have similar triangles, the trigonometric ratios are equivalent. So which trigonometric ratios are correct for triangle XYZ? We notice right here, first off, we have 8 and we have 15, but we're missing the hypotenuse length. So the first thing we have to do is say, well, I need to use something to find that hypotenuse, and that something is probably going to be the Pythagorean theorem. So if we have a squared plus b squared equals c squared, then we can say 8 squared plus 15 squared is equal to c squared. So that's 64 plus 225 is equal to c squared. And if we take the square root of both sides, we're going to find out that c is equal to 17. Once we know the length of the hypotenuse, then it's a simple matter of finding out what these are. So let's look first at the tangent of y. We're looking in relation to this angle. So we say opposite is 8 over adjacent is 15. That is correct. Cosine of x. Now we're looking at this angle. So make sure you're paying attention. If it says cosine of x, we've got to look at x. So x is adjacent 8 over 17. So that is not correct. Tangent of x, opposite over adjacent, 15 over 8. That is correct. Now we're looking at sine of y, so we're back up to this angle. Sine of y is opposite over hypotenuse, 8 over 17. That one is correct. And the cosine of y, because this is not a 45 degree triangle, I can tell you that those two are not equal, because that's the only time we're going to have sine and cosine be equivalent is if we have the angles equal, and they're not. So we know that that's not true, and the cosine should actually be 15 over 17, which is adjacent. All right, so if you have any other questions, let me know. Hopefully that helps you with trigonometric ratios.